since he graduated with his PhD in the, a long time ago. Don's career and interest and expertise can be summarized as sunlight and sea ice, which sort of encapsulates his investigations over the years into the heat and mass balance of mostly Arctic sea ice, but I believe Don has been at least once to Antarctica, so we can call him bipolar. And our third speaker is Dr. David Bromwich from the Bird Polar Research Center at Ohio State University. David is also a modeler. He's done a lot of weather and climate modeling in the Arctic, and particularly for Greenland, and in the Antarctic. And without further ado, I would ask Marika to begin the presentation, please.
Great. So let me just get this set up. All right. So on behalf of myself and my co-presenters, I'd like to welcome you all to the webinar. So we're going to be talking about the Year of Polar Prediction. And as Martin mentioned, this is an activity under the Polar Prediction Project. So I'm going to start it off giving some overview material on what this is and the motivation for it. And then I'll turn it over to Don, and he's going to talk about the observational objectives under YOPP, the Year of Polar Prediction. And then Dave Bromwich will finish up with information on the modeling objectives of YOPP. And then we will conclude and take questions. So in terms of the motivation for YOPP and the Polar Prediction Project more generally, a lot of this is motivated by the fact that there are significant gaps in polar observing systems, as you can see here. So this shows the data coverage of conventional observations that went into the ECMWF operational analysis on a specific date. And you can see for the Antarctic region, the lack of observations. There's very few conventional observations going into these operational analyses. And then on the right, the Arctic observations, and there are more in the northern polar regions, but you can still see some very serious data gaps here. And of course, this has implications for our ability to initialize predictions. And the Polar Prediction Project and YOPP is really focused on the hourly to seasonal sort of prediction timescale, not the long-term prediction. There have been a lot of previous efforts focused on lower latitudes and improving predictions in those regions, but there's been a lot less focus on polar regions. And there's some unique characteristics of polar regions which are important in terms of improving predictions. So as one example, this shows the 2-meter temperature difference in forecasts for different timescales. So from 2 to 5 to 7 to 10 days on the lower right panel. And these are differences between forecasts in which sea ice conditions are persisted from the initial state and forecasts where the sea ice is allowed to evolve over time. And you can see that there are these considerably larger errors in these sea ice covered regions in the forecast which use persisted sea ice conditions, which is something that's commonly done. So even when you're talking about these weather timescales, these unique characteristics of polar regions, sea ice cover, how that influences the evolution of the atmospheric state are very important. And this suggests that we really need to move more towards coupled prediction systems in order to capture some of these feedbacks and interactions. And it is quite clear that our forecasts in polar regions are deficient and that there is a real need and the ability to actually improve these forecasts. So this shows an example of the spread in the analysis for 2-meter temperature on the left and 500 hectopascal height, geopotential height on the right. And you can see again that the polar regions really stand out as having a large uncertainty in their initial state, which is what's shown here for a number of different analysis systems and then forecasting systems. And then those in turn influence deficiencies in the forecasts in these regions. And finally, with large-scale and long-term changes that are occurring in these regions and in sea ice in the Arctic in particular, we're having enhanced access to the Arctic, and that has really raised the need for reliable forecasts in these regions. In addition, there's the potential that improving predictions in the polar regions can in turn improve predictions in mid-latitudes. And so there are these linkages between the polar regions and lower latitudes, which can be important for the prediction problem. So this shows an example of that. This is a study by Thomas Young, published last year, in which they were doing forecasts, but they were nudging the Arctic state to reanalysis, to an observed state essentially, and then looking at how that improvement in the polar regions can propagate into the forecast in other locations. So this is showing the percent reduction in forecast error at different time scales in the forecast. And of course, you see this large improvement over the polar regions, which just is because that area is being nudged towards the observations. But you can see that the influence of that extends well beyond the Arctic region, and in particular on this longer 11 to 30-day forecast range, you see it reaching mid-latitudes. So there is this potential that improving predictions in the Arctic region and in the high southern latitudes as well can in turn improve predictions in mid-latitudes. So that provides a lot of the motivation for why there is this polar prediction project and why there's this focused activity called the Europolar prediction. And I will note that this activity is actually bipolar, so it's not just for the Arctic, it's also for the high southern latitudes as well. Although a lot of what we'll be discussing here is focused on the Arctic aspects of this, since this is an IARPC telecon or webinar. So this Europolar prediction is really the flagship activity of the World Weather Research Program Polar Prediction Project. Its goal is to enable significant improvements. There we go. To enable significant improvement in environmental prediction capabilities for the polar regions and beyond by coordinating a period of intensive observing, modeling, prediction, verification, user engagement, and education activities. And I'll just emphasize that this is talking about environmental prediction. So included in this is not just weather prediction, but also things like sea ice forecasting. So it's kind of a larger scale environmental prediction effort that's being invoked here. In terms of the phases of YOPP, so there's this core phase that will occur from mid-2017 to mid-2019. And we'll be going into quite a bit of detail on what that involves. But we're sitting here in the preparation phase for YOPP, which started some time ago, and there have been some planning meetings associated with YOPP. There's also an implementation plan that has been produced and is available, and I'll give the URL for that later in the talk. And associated with this preparation phases are also things like this webinar. And then finally, after this core YOPP period, there will be a consolidation phase to really capitalize on this intensive YOPP effort. So in terms of that, the preparation phase, which is where we currently are in the plans for YOPP, this phase is meant to develop a strategy for YOPP, engage stakeholders in the YOPP effort, coordinate programs, observations, modeling activities, et cetera, and do some preparatory research. There have, as I mentioned, have been some YOPP planning meetings already held, and there is this upcoming YOPP summit, which will occur this summer in Geneva. So the dates are set, 13th to 15th of July. And this YOPP summit is a high-level meeting for the preparation of YOPP. So researchers, representatives of weather and user and service centers, funding agencies, decision-making parties, et cetera, are invited to this summit. And it has a lot of the planning activities and the coordination of those, things like the data legacy for YOPP, priorities for YOPP, all of those things will be discussed at this summit, and those will actually inform the second iteration of the implementation plan. So that's a big activity that will be happening in the very near term, and there's something like 200 people that will likely attend that meeting. An invitation or save the date information is out for that, and invitations for that, formal invitations, will be out, I believe, in the next week or so. In addition, there are education efforts associated with YOPP, and there's a polar prediction school that is planned, and this is joint with the World Climate Research Program Polar Climate Prediction Initiative, and this will be held in Sweden in about a year. So there's this there's an educational effort associated with this as well. Sorry, I hesitated because I saw a chat come up, but I don't think it was directed at me. So in terms of YOPP itself, the core period of YOPP occurs from mid-2017 to mid-2019, and it has four major elements: an intensive observing period, a complementary intensive modeling and prediction period, a period of enhanced monitoring of forecast use in decision-making, including verification, and education efforts associated with it as well. There are a number of objectives under YOPP, and my co-presenters are going to go into these in more detail. Just to run through them quickly, these are the objectives that fall under the observational and modeling aspects of YOPP. It includes things like improving the polar observing system and doing things like carrying out observing system simulation experiments to guide observations, gathering additional observations to inform and better understand polar processes, improving the representation of polar processes in models, developing improved data assimilation capabilities, exploring the predictability of the atmosphere, cryosphere, ocean, and again, the focus of PPP, the Polar Prediction Project, is on timescales from days to a season, and then improving our understanding of these linkages between polar regions and lower latitudes and assessing the skill of models in representing these. So at this point, I'm going to turn it over to Don Perovich, and he's going to talk about the observational objectives under YOPP. And I will be continuing to run the slideshow from my computer, so Don will need to tell me when to advance the slides.
Thanks, Marika, and thanks to everyone for phoning into this. YOPP is very interested in observations, and from an observational perspective, it has two main overarching objectives. One is to improve the polar observing system, primarily by carrying out observing system experiments. And by that, the idea is to determine what are the most critical observations that need to be made and where is the best place to make them. So the second objective is to gather additional observations through field programs aimed at improving the understanding of key polar processes. So if you put these two objectives together, it's to determine what are the key observations and where to make them, and two, what observations can we make to improve our understanding of the important processes. Next slide, please. And this is the same timeline that Marika showed earlier, and we see in the preparation phase, observations come in under the align with other planned activities. And then the year of polar prediction from 2017 to 2019, it comes through in intensive observing periods. So let's take a look first at what's going on right now in the preparation phase, how things are being aligned with other planned activities. Next slide, please. And so the key for this period from a YOPP and observation perspective is to reach out to the observing community, to start a dialogue, to first find out about what observational efforts are ongoing and what are planned for the future, and then in turn explain what the YOPP activities are planned. And the idea is to work to coordinate observations and modeling to get the best combination of the two, and to promote in some areas additional observations that will be beneficial to YOPP, and also to explore key processes. And this can start by using additional results in data denial experiments. And this conversation has been ongoing, and I think it will really continue, and there'll be a lot of discussions at the YOPP planning meeting that Marika talked about that will be happening this July in Geneva. Next slide, please. And as we go into the Europolar prediction in 2017 and 2019, we see that one of the key elements is this intensive observing period, where we tap into comprehensive reference stations, field campaigns, observations, and satellite data. So let's take a closer look at some of these activities in the next slide. And the purpose of observations for YOPP is threefold. It's to develop a comprehensive observational snapshot in order to improve the initial conditions for the models, to help model development, and finally, to help verify forecast. And there are four elements that will go into this observational effort. It's comprehensive reference stations. These are existing stations to make the best possible use of their observations. Also to tie in with ongoing field campaigns both in the marine and the terrestrial environments. And also to have select intensive observation periods to look at particular sub-elements. And as part of these intensive observation periods, there will also be extra observations of areas of key importance, such as the free troposphere, the planetary boundary layer, and clouds, sea ice, ocean, snow, and land. And while doing this, in addition to making use of existing stations, there will also be extensive use of autonomous sensor systems. And there will also be an outreach to stakeholders to see what observations can be made by stakeholders, for example, ships that happen to be in the area and other things similar to that. And there'll be satellite data, and the satellite data will have a dual purpose. We'll be able to use that combined with the in situ observations to improve satellite retrievals, and also the satellite data will be used to provide a large-scale snapshot of what's going on in the polar regions during the YOPP field the Europolar prediction in 2017 to 2019. Next slide, please. And the key to this is making connections to tie into ongoing efforts to get as much synergy as possible. YOPP has been reaching out to various organizations and other efforts such as the Climate and Cryosphere, Scientific Committee on Antarctic Research. It's also been trying to see what's going on in ongoing efforts for the Sustainable Arctic Observing Network, the Southern Ocean Observing System, the Sea Ice Prediction Network. It's already exploring what's going on in terms of the North Pole Drifting Station and also existing land-based flagship observatories such as Tixie, Summit, Eureka, Dome C, South Pole, and also to see what's available and what may be needed in terms of autonomous instrument platforms and automatic weather stations. And just to give an example of some of the discussions that have been going on, I want to focus on just one of these many elements, and that's Mosaic. Next slide, please. YOPP has been discussing, going back and forth with people organizing Mosaic. Mosaic stands for the Multidisciplinary Drifting Observatory for the Study of Arctic Climate. It's a program that's currently in its planning stages with the hope of having a field experiment starting in 2018. And that the key question the Mosaic is addressing is that what are the causes and consequences of an evolving and diminished Arctic sea ice cover? And it plans to address this question through a multi-year coordinated comprehensive experiment with lots of in situ measurements that will extend from the top of the atmosphere down through the snow, the sea ice, and into the ocean, and get an idea of what's happening in the atmosphere, ice, ocean, biogeochemical system. And as you can see in the cartoon in the middle of the page, Mosaic is focusing on what's going on to achieve a process level understanding. And with this process level understanding, it'll be possible then to improve modeling of Arctic climate, weather, and sea ice. Next slide, please. And I think the discussions that have been going on between YOPP and Mosaic illustrate how there's mutual benefit to these sorts of interactions. Mosaic has the ability to make significant contributions to YOPP by providing observational basis for model development. and that it'll also be able to contribute to the Pan-Arctic YOPP observing system in two ways. One, by the measurements that are made directly as part of Mosaic, and also it'll provide a platform to support other observations such as cruises and aircraft overflights, and it'll be a place to provide ground truth for the satellite community. In turn, YOPP can contribute to Mosaic. It can contribute right now in terms of experiment planning. It can provide forecasts both in the planning stage and during the execution of the field campaign. And it has the ability to conduct model runs at various resolutions, and also to provide a Pan-Arctic context for the observations that are made in and around Mosaic. Next slide, please. And finally, from an observational perspective, YOPP, it's all about the data. And there are three significant data challenges for YOPP. The first is to integrate data from a wide variety of sources. Second, and this is somewhat unusual, it's to make this data accessible in near real time. And finally, to establish a long-term data archive. And these are big challenges, but they also, if they're met, they'll have big rewards as well. So I'd like to turn things over to David now.
Okay, thank you, Don, and welcome everybody. Appreciate you attending this webinar. So I'm going to be talking about the modeling objectives for YOPP. Next slide, please. Just to go back to this activities under YOPP, and in particular the modeling. So there's this intensive modeling and forecasting period, as we've already talked, from 2017 to 2019. It will have high resolution and coupled forecasts, and we'll talk about how to develop those. Of course, the model output and reforecasts will need to be archived. We've already talked about field campaign support, in particular for Mosaic. An important component of this is modeling the sea ice cover in both polar regions, and there will be a component of subseasonal to seasonal predictions, which is out to approximately 2 months. Next slide, please. So the modeling objectives, to re-emphasize, to develop improved representation of key polar processes, both in uncoupled and coupled models used for prediction, to develop improved data assimilation systems, so that's to get the initial conditions for the forecasts that account for the particular challenges in the poorly observed polar regions, and to explore the predictability of the atmosphere, cryosphere, ocean, with a focus on sea ice, and again on timescales from days to a season, and importantly, improve the understanding of linkages between the polar regions and lower latitudes, and assess the skill of models in representing these. Next slide, please. So I've put down a few key polar processes that it would be nice to do a better job on to enhance the reliability of the forecasts. And everybody's favorite one is the stable boundary layer, where the temperature near the surface is much colder than that aloft. And particular aspects of this, the interaction with stratiform clouds, that's mixed phase clouds, and how they evolve over snow-covered surfaces, so sea ice, snow on land, Greenland ice sheet, Antarctica, and so on. Then there's the issue about dramatic changes in the stability of the lower atmosphere, going either from the Arctic sea ice to the North Atlantic, or conversely going from the warm North Atlantic to the very cold Arctic, and how the boundary layer and also the clouds and the fluxes respond to those sharp changes in the lower boundary condition. Formation of low-level clouds, particularly in the Arctic, but also over the Southern Ocean, is proving to be very problematic and still not very well observed and certainly not very well predicted. And so continuing investigations of the role of horizontal as well as vertical moisture advection in the formation of these clouds, the role of turbulence, and aspects are that there's very low concentrations of cloud condensation nuclei, that's for liquid clouds, and ice nuclei for ice crystals. So one of the most important aspect is the mixed phase clouds, where we have liquid and solid together. When we're coupling with sea ice, then we need to get accurate simulation of these small-scale structures in the sea ice field, such things as leads, small cracks, linear cracks in the ice cover, ridges where the sea ice piles up, what happens at the ice edge, you might call that the marginal ice zone, and the impact of waves that can propagate some distance into the sea ice cover. I'm not talking about it very much here, but obviously the Arctic Ocean in particular is surrounded by extensive land where seasonal snow cover builds up and where there are very major rivers flowing northward into the Arctic Ocean. So you would ideally want to do a very good job on these polar processes. Next slide, please. So data assimilation. So this is the initial condition of the models that start out to forecast conditions. And when we're talking about adding sea ice, then coupled data assimilation moves to the forefront. And especially an important problem is how to specify the initial state of the sea ice. So that means things like not only the fractional coverage of the ocean surface by sea ice, but how thick the sea ice actually is itself and how much snow cover is sitting on top of the sea ice cover and how deep it is. And then when one is doing data assimilation, you need to know the uncertainties of the coupled model forecasts of the atmosphere, the land, sea ice, the wave, and the ocean components. Ideally, after one has done the coupled data assimilation, not a trivial undertaking, it would be best to develop ensemble predictions which are used for in the atmosphere for forecasts of say a few days out to 10 to 15 days. They're highly desirable. Another important part of data assimilation development is the effective use of satellite observations over snow and sea ice. That's both retrievals where you actually get like the temperature profile and the moisture profile, or use of radiances, satellite radiances directly. And that's a challenge over snow and sea ice, as is well known. Particularly for the Arctic, it's surrounded, as I said earlier, by this extensive land area. And so how well we're actually putting the initial conditions of the land surface, for example, the snow cover, how deep it is, what its water equivalent is, the moisture in the soil, whether it's liquid or solid or some mixture of the two, and depicting the permafrost, and also on the evaluation of these analyses that we have from different centers, both seasonal snow cover and in the soil. And snow cover on sea ice is particularly important for the the heat and energy budgets over the Arctic Ocean, and it's not good observations at all on that. And although this is not a major component of YOPP, at least in the Antarctic and to a lesser extent in the Arctic, what's going on in the stratosphere, and in particular the impact of ozone and its depletion, have a role in what's happening in the troposphere. So that's a component of improved assimilation. Next slide, please. Another aspect of the modeling is to explore the predictability of the coupled system, the atmosphere, cryosphere, ocean, which would involve forecasts and reforecasts to assess the forecast skill and diagnose the source of forecast failures. Sensitivity studies to explore the role of model formulation on predictability metrics, and of course all important case studies to assess the predictability forecast skill of particular extreme events. And there one might focus on something like the extreme minimum Arctic sea ice cover in like 2012, for example, and see how forecastable that is in advance. Multi-year free model runs to assess biases in simulation of mean and variability characteristics, and potential predictability studies to explore the inherent limits of predictability, particularly for sea ice and other variables. Next slide, please. And this is a very, very popular area, and so YOPP can contribute to the many, many aspects of research going on, looking at the linkages between polar and lower latitudes, particularly in the Northern Hemisphere. Aspects are to quantitatively assess how the linkages translate into remote origins of predictive skill and the converse of forecast failures in order to guide forecasting system development. Use of YOPP-related model simulations, including sensitivity runs and predictability experiments, to explore the mechanisms that result in linkages, and use of model sensitivity runs to quantify how much of the actual and potential predictive skill in the polar regions originates in lower latitudes, and in parens you might put in from the tropics. Next slide, please. So additional YOPP objectives that we won't be discussing here very much is improved verification of the predictions themselves. So how do we do this most effectively in areas where there's not very many observations and where there's some unique environmental phenomena taking place? Another aspect is improve the understanding of the benefits of using existing prediction information and services in the polar regions. How well is the information currently provided? How well is it used? How well is it understood? Those kind of issues. And we've already talked a little bit about the third bullet, which is to provide training opportunities to generate a sound knowledge base on polar prediction-related issues. Next slide, please. And I'll finish here, and thank you for your attention, and I'll turn it back to Marika.
Yeah. Thanks, Dave. So in addition to this intensive year, or actually 2 years of the YOPP, there will be a follow-on consolidation phase that's planned for mid-2019 to 2022, and this will be basically some of the YOPP legacy. So using the YOPP data, the maintenance of a data archive, workshops and publications, making sure that the findings under YOPP effectively make their way into improved forecasting systems, improved satellite retrievals, et cetera, and then the evaluation and feedback from stakeholders and things of that nature. So there is this, YOPP has this kind of long time frame, even though there's this intense core period. And finally, there are implementation plans both for the Polar Prediction Project and for YOPP itself. And so there's a lot more details in these implementation plans for anyone who's interested. So the location of these is at this polarprediction.net site, and so you can download them and read through them. And as I mentioned, this implementation plan for YOPP is basically a living document at this point, and so it will be updated after the YOPP Summit in July, and version 2 will be available sometime later this year, probably near the end of this year, based on what comes out from the YOPP Summit. So with that, I think we'd like to open it up for questions, and I think all of us can take questions. So thank you.
Yes, thanks, Marika. And I'll remind everybody, you can either type your question into the chat box, and I'll, again, send a message to everybody. And if you type your message in, I will read it for you, or you can use the raise hand function to alert me that you want to speak your question, and I will unmute you.
So could you just let us know exactly how you do the raised hand? I'm not sure that everybody might understand that.
I don't know. That's the problem. I don't have it because I'm the host.
Okay.
Sarah, could you, let me unmute Sarah and see if she can explain. Oh, you are unmuted, Sarah. Sarah, Martin is with you, so you're unmuted. We can all hear Martin.
Sorry, we were on mute in the room. So it's on the participant. If you click on participants, you'll see a little hand, and you should be able to click that hand and raise your hand.
Okay, and John says it's under View All Attendees bar.
So Jessica, we've raised our hand here. You should be able to see that.
I do. I see your hand raised. I don't see any other hands. Oh, I see Jim Overland has his hand raised, so I will unmute you, Jim, and go ahead and ask your question.
Thanks for the presentation here. A question for Dave. What are there plans here for how the model improvements will get into the operational centers, because that seemed to be a major theme for WWRP.
Thanks, Jim. Well, the very encouraging thing here about the World Weather Research Program is that the major operational centers are actively involved in the Polar Prediction Project. Certainly NCEP, ECMWF, and the Canadian forecasting effort. So that's basically almost guaranteed from the outset. And furthermore, having the major operational centers, forecast centers involved, provides substantial resources to just a pure research program. Thank you.
Anybody else have a question? Don't see any more hands right now.
So since our hand is still up, I'll put in a question. Can you hear me?
Simon, yes, and then WeFlaw will be next.
Okay, so in the presentation, you discussed a little bit about the YOPP and Mosaic interplay between shorter time scales and longer time scales, the Mosaic in the climate realm. And I was wondering if you could talk a little bit, any of the presenters, because you all have worked in the, in both realms, whether you see YOPP per se informing the climate discussion, even though the focus is on hourly to seasonal.
So I'll take a first stab at that and then let others chime in. But yes, I think that this definitely can lead to improvements on the climate timescales as well. So a lot of those processes that Dave went through in terms of the targets for improvements in models, those things are issues in climate models as well. And so if we make improvements in them under the YOPP efforts, I think those things will feed directly into improvements for climate modeling as well. And I think the process level understanding that Mosaic is focused at, I mean, part of the reason that YOPP wants that information as well is that they need to improve models in those physical processes as well. And that would be a benefit across timescales.
Okay, thanks.
Can I ask a question too? Hi, Marika. This is Anjali. Thank you to all three of you. My question was a follow-on to Simon's in that WWRP will be focused on the shorter time scale, and there's this WCRP polar predictability initiative as well. So would it be, is it accurate to say that the polar YOPP will focus on the fast physics of the problem, and the WCRP will go on to biogeochemistry and carbon radiative forcing and some of the longer time scale processes and feedback? So YOPP will not address those kind of processes.
Right. So that is the case. And so this Polar Climate Predictability Initiative, which is the WCRP kind of counterpoint to the Polar Prediction Project, I mean, we're thinking of these as basically sister projects. There's been a lot of interaction between the two communities, things like the summer school that's being planned in Sweden, it's a spring school, but it's a joint effort between PPP and PCPI. And so, and they also share a project office. So, so that is kind of where the handoff occurs, but there's a lot between the seasonal and longer timescale sort of prediction. But those efforts are very well aligned. There's a lot of coordination and communication going on between them. So I think that that can happen quite well, things that are knowledge that's gained at this shorter time scale out to seasonal prediction will inform things, and that will partly be done through this coordination with PCPI, which is the WCRP project. I'll also say things like improvements and developments of coupled data assimilation systems are very important for the decadal prediction problem, which is a big focus in the climate research community right now. So I think that knowledge gained in terms of how to do better data assimilation will also inform those climate prediction, decadal prediction efforts.
Thanks, Marika. And Wisla had a question, and I have unmuted you, Wisla. Go ahead if you're ready.
Okay, thank you. Thank you. So I really appreciate all this information that was provided because I've seen it so well presented first time. But my question and what I was missing from those slides is that it looks like there are participants and there's already activities underway and there's some phases of this effort. My question is just who is funding it at present and who are potentially future or expected funding sources?
So, I mean, I think that's going to be a big topic of conversation at the upcoming YOPP Summit. There are different groups that have shown an interest in contributing, and as Dave mentioned, the operational centers, ECMWF, NOAA, other people with or institutions with an emphasis on operational forecasting have expressed a lot of interest. But exactly the funding and the details of that is something that is still being determined in this preparation phase. So actually at the back of the implementation plan that currently stands is an activity contribution table, and it talks about different contributors and what groups like the British Antarctic Survey or NOAA or other groups have kind of mentioned in terms of contributions to YOPP. But some of this is still being worked out, and that's part of what this preparation phase of YOPP is about. And I don't know if my co-presenters have anything to add in that.
This is David Bromwich here. Part of the reason for having this webinar is to bring the year of polar prediction to the forefront with the funding agencies to see how they can participate. And of course, that's particularly important in the US way of doing things. In other countries, they've got more, established programs like the operational centers, for example. So I think we're at the state now of hoping that the US agencies will act to support in ways of their choosing the year of polar prediction. Thank you.
How are you? Can you hear me?
Yes.
This is Eric Saltzman. So is there a plan, an integrated plan for engagement with Native peoples in this project?
So there is some discussion of that under services and those kind of efforts. And I think there's more in the works for that, but I have to admit, I don't know a lot of the details on that part of the plan and exactly how far along that those efforts are. Maybe Dave or Don know more.
Yeah, I think it's certainly something that's been talked about, but I don't think it's in a completely mature phase right now.
Okay, thanks.
Are there any more questions? Chris Farrell, I will unmute you, and please go ahead.
Yeah, can you hear me?
Yes.
Yep.
Yeah, the question from Eric is there is an entire component of the PPP dealing with societal interactions, and the Native peoples are a major part of that. It's written into the implementation plan and all that. So if you get out the implementation plan, it's in there.
Okay, thanks, Chris.
Yeah, so Chris is also on the steering group for the Polar Prediction Project. So thanks, Chris.
Hayo has a question, and I will unmute him. There we go. Hayo, go ahead.
Well, it was more a comment. Chris already answered that in part. There's several working groups that are looking at this. The other point that may be of relevance is that NOAA's Arctic test bed, which has just been implemented and is a longer-term activity, does have both the potential and ongoing activities to incorporate indigenous expertise. There's the CS for Walrus Outlook that takes community-based observations by indigenous hunters and compares that with model forecast system output as well. So if that continues over the coming years, that would be one potential way to achieve that.
Thanks, Hayo. This is Martin. We're approaching 4 o'clock, so we're already running over. So if there are maybe just 1 or 2 more questions, and then we'll conclude.
Scanning for hands. I don't see any new hands going up. think that's it.
Simon has a question.
Yeah, so one part of the presentation you talked about the design of observing systems, and my question here is similar to my first question. Is there, do you see the design focused primarily on the shorter term timescales, or do you think this will again flow into longer term questions?
Yeah, so the focus for the design is on prediction on these shorter timescales. I think that that can inform predictions needed for longer timescales as well. And I speak mostly from the CI's perspective, which is where I've actually done work in this area. I think that a lot of the studies that would probably be undertaken would look across kind of seasonal to interannual timescales. So while the focus really is on shorter timescales, I think it could definitely help inform longer timescale prediction as well.
Okay, there are no more hands, so Martin, if you want to conclude.
Okay, thank you, Jessica. Marika, could you go to your last slide, please?
Yes.
So in response to perhaps to Wisław Maslowski's question a moment ago about who's funding, you'll be encouraged to know that part 2 of our meeting this afternoon is going to be a discussion among only U.S. federal government agencies that fund research in Arctic to begin to discuss what our contribution might be and how we might support research that would contribute to YOPP. And these are the sorts of questions for the benefit of the federal funders in the room and on the phone that we're going to address when we go into this closed session. So a peek at our questions for those of you from outside the federal government, just so you know what we're going to talk about. And be encouraged, I hope, that we are going to begin to address this question of a U.S. government contribution to this international year of polar prediction. So with that, I'd like to thank our speakers, Marika, David, and Don, for taking the time to prepare your slides and spend your time this afternoon with us, telling us about Year of Polar Prediction. Some of us have known of it for some time, but this is probably the most information we've seen about it, and I'm sure there's lots more to come as we get closer to 2017 and the actual implementation. So again, thank you very much for sharing that with us, and with that, I will close the public webinar